So it wants their stuff to be successful. They want their APIs to be used. They want their user interfaces and programs and applications to be used, et cetera. So that's the primary thing is, can you solve real problems with it? And can you get the feedback from those consumers and developers early enough to tell you you're on the right path?
I'm Jason Harmon, and this is API Intersection, where you'll get insights from experienced API practitioners to learn best practices on things like API design, governance, identity, auth, versioning, and more. Welcome back to API Intersection. I'm your host, Jason Harmon, CTO at Stoplight. And today's one of those days where, I don't get as much time as I like to go read and learn new stuff. But every now and then when I do get the chance, there's people I trip across that I just think, I want to meet these people. So our guest today, David Biesack, I hope I said your name right. I forgot to ask before. All right. Chief API Officer, cool title at Apiture, is going to join us today. And we'll kind of talk about, talk shop, talk API stuff. So thanks for coming, David. Tell us a little bit about yourself and what you guys do.
Yeah, thanks for inviting me. So I'm Dave Biesack. As Jason mentioned, I'm the Chief API Officer at Apiture. I joined the company when it was founded a little over 5 years ago, and they set out to become a banking API platform. So they wanted to build APIs around their banking solutions and brought me on board to help build the API program there. So I started out as an API architect and then eventually moved up to where I am now as Chief API Officer. So I'm responsible for the design and architecture of our APIs. Most of the time I spend in doing that analysis and design. I work with the product folks who come up with feature requirements, and then we map them into APIs. And then I do API design along with another API architect on the team. His name is Aaron. So we convert all the basic feature requirements into APIs, and then the engineering teams go and implement all those APIs, deploy them, and help us secure them, et cetera. So most of my work is around designing those APIs, but all the ancillary things that go along with that as well. So training other folks on what it means to be an API-first company and what it means to try to design APIs up front. And really what we do is try to gather those requirements and make them separate from just UI requirements or API requirements, but just be feature requirements and then build APIs around that. So I've been doing that ever since.
Very cool. You're our people. You're amongst good company. I think there's a lot of folks trying to do the sort of thing that you're doing and the thing that I've done before, which I think is very similar, I think, in our audience. So you're in good company. Mm-hmm. And you did a heck of a stint at, I guess, SAS before this, right?
Yeah, I worked at SAS for 28 years before coming to Apiture. Built a whole career there, doing all kinds of things, but I spent my entire time in the R&D organization. When Java came out in 96, I helped SAS adopt the Java platform. So I was, my role there was similar to what I do at Apiture as Chief API Officer. I was the R&D Java strategist. So I helped define Java standards for the entire organization, did a lot of training on Java adoption and building libraries, things like that. And then the last 5 years at SAS, I ran the API Center of Excellence, which was a governing body. So we helped shape the REST API standards for SAS and worked as a consulting organization and helped all the teams design their REST APIs according to those standards. Worked on tooling around APIs and things like that. So it helped with the adoption of APIs throughout the R&D organization. And in those 5 years, we had an API review process, and we had about 120 different APIs that we brought through that design and review process while I was there.
Nice. So I guess bringing it back to kind of what caught my attention is you'd started this blog post series that you titled The Language of APIs that I think somewhat hubs around OpenAPI, but I feel like you touched on a bunch of other stuff too. So, I mean, kind of what do you feel like is the big point that you're working to get across in this series?
Yeah, so I've always been kind of a language geek throughout my entire professional career. So I was always interested in programming languages, as I mentioned, helping with the adoption of Java at SAS, et cetera. I was always intrigued by the expressiveness of languages, how well they can capture your intent as a developer, as a programmer, how concise versus how verbose those languages are. And Java is kind of known as a relatively verbose language, but certain language attributes can help improve that with type inference and things like that. But basically, how do they work as languages for communicating ideas? Our human language is used for expressing ideas and communicating with each other. Programming languages are used for communicating with the compiler and the backend and the runtime, but also for communicating with other people who are going to be reading those programs and reading that code later. And so the idea of how well you can express your ideas in those languages is really intriguing to me. And more so, how those languages change over time and the way we use those languages changes over time. And in fact, it comes to be that oftentimes those languages influence the way you think about things. So the solutions to a programming task using Java are very different from the solutions you might come up with using a functional language like F# or Scala or even TypeScript and stuff. So that's what I'm really interested in is this notion of languages, how they capture ideas, how well you can express your ideas in them, how they grow, and then how you as a programmer or developer grow along with those languages as you acquire those languages and become more fluent.
It's funny. I think for a kind of fundamentally technology-oriented podcast, I think we probably, if we could ever figure it out, might have set a record for the number of professionally trained linguists and just language geeks. I feel like it's an occupational hazard of when you work with APIs too much, all of a sudden words take on a whole new meaning.
Yes.
I mean, like my favorite example is like when someone says the word metadata. I'm like, the word means nothing. I mean, it's just an empty, vacuous hole of meaning.
Mm-hmm.
You have to describe what it means, and it usually means you didn't think about what to call it. You get hangups, right? So I love this focus on language. I think one thing we've heard a lot from other practitioners is the idea that the words, so you're talking about kind of programming languages and that expressiveness, which is fascinating, and we might come back to. But in terms of describing your platform, when you think about not just designing one API, but designing a whole portfolio of things, that the words that you use carry greater meaning. And that a lot of folks, when we ask them, what would you do if you started from scratch? They say, define that language. So I'm curious, like in terms of domain definition or capability definition, whatever you want to call it, how do you approach that sort of thing?
Right. And this was one of the most widely read and shared articles that I wrote in this series. I wrote about, using domain-driven design, and a lot of what we do at Apiture is based off of James Higginbotham's book, where he talks about this ADDR process. And the title of that article that I wrote was that API design first is not API design first. Everybody hears about API design, API first this, API first that, but that's really a misnomer or mischaracterization, because you don't start with the API no matter what you're doing. You have to go back to business requirements and what problem are you trying to solve? What problems do your users or potential users have that can be solved, hopefully with an API? And really it's understanding that and using the techniques of domain-driven design to characterize those problems. And then an important part of that process is building the ubiquitous language. What is the set of terms, the vocabulary of your problem domain? And then making sure everybody understands and agrees on what those terms mean, so that you're removing ambiguity as you move forward and go through the rest of the process. So it's really important to build that vocabulary so that everybody understands things from the get-go. And it starts with that, the product requirements and understanding the domain in which this problem resides, and understanding what those terms are. And then you have to codify those in some way. So they actually become names of, when you do API modeling, they will filter down and often become names of resources in your API model, or they may become the names of operations in your API model. But that's where I really want people to start is going back to the source. What is the problem you're trying to solve? And then how do you capture that with the language? And design patterns were a really popular thing 20, 30 years ago. And really what was important about design patterns was this whole notion of a pattern language, which is what you use to document the problems and the forces, and then the patterns that you use to solve those particular problems. And I like to see the same mappings happen with APIs as they do with just general software development. Is you build a language and you have a way of expressing either the problem set or the solution set with specific languages. And some languages are good for that, and some languages need some work. But that's really what intrigues me about this, and understanding how languages influence people and the way you think.
Yeah, I always I think when I've tried to describe this to people, I'm like, if you had to draw a very naive sort of graph of the conceptual names of things in what you intend to build, and you just put it on a big marker board and you walked customers in the room, would they point and go, "Oh yeah, that's my stuff"? Would they recognize quickly, conceptually, what it is that they intend to do out of just the language without anything further? Do you use any, you mentioned kind of DDD as sort of the methodology that you're using. Are there any sort of specific tools that make that process of aligning around language easier for you?
No specific tools. James in his book, he outlines some tools and techniques for doing things with like spreadsheets and tables of defining various things. We've kind of extended it. To me, spreadsheets are a little bit awkward to work with versus we use a wiki primarily. So our product team uses various tools that product managers like to use for capturing, epics and higher level goals and things like that. So this is what this product or this feature is going to do. And then they break it down into components, and they use various tools for that. And eventually things filter down from that method down into things that become, Jira tickets. We use Jira for tracking activities and our sprint cycles and things like that. So a lot of things come down as Jira tickets. But what I do is I have to consolidate all that information from all these different sources, from interviews with the product people. We sit down and have meetings, and we go over and ask questions and things like that. And then we just basically capture everything into an API model that we capture just on a Confluence page as a wiki page. And it's very easy to collaborate on that. So we can go in here and we can kind of give a high level view. What I do is I do this translation exercise. I take what they give me as product requirements, and then I rephrase it and kind of speak it back to them and say, is this the right way of picturing this or representing this? Do I have all the elements captured? Is this a correct representation of what you've told me? And we iterate on that. And because when I write things down this way, then it will often raise a lot of questions. And so I will write those questions down, and then we can iterate on that Confluence page, and people can add questions and write responses in there, and it evolves over time. And it's pretty easy to modify and extend that API model as we learn more and more. And the top of the document is where I list, the vocabulary. I list what are the common terms for this domain model, and we make sure people have a common understanding of that. And then that filters down into the lower level of what those API resources are going to be. And that tends to work really, really well versus something like Jira, which tends to fragment your knowledge and put in lots of different places that it's oftentimes really hard to get the bigger picture of how things interrelate. You can have an epic that's got 20 or 30 stories in it, and you have to click on each one, open a page, read what's in there, read the acceptance criteria, and then go back to the next page and the next page and the next page. By the time you get through the whole thing, you've kind of lost track of where you are and trying to figure out, where did I read that initial requirement about this one specific attribute or this one specific behavior? It gets lost in my mind. So by consolidating the domain model, the knowledge base into a Confluence page really helps me. And it's guided by, again, with domain-driven design, is these bounded contexts that really kind of fit naturally into your API models. So you have an API and you focus really on what is the core element of that API? What is the primary resource? And what are the pieces necessary to pull that together? And you can certainly have related resources, and you can have sub-resources, et cetera, and you can explain all that. But usually that one wiki page talks about that one specific domain model, and it try to coalesce all the information we need there in order to then, once we've narrow that down and we've got the basic API model worked out, then we can transcribe that directly into an OpenAPI document and start building that. And that becomes more of the design art of how you capture that into one or more API documents. We have a multi-document design. So we have an API that's just called common, which is one OpenAPI document that has a bunch of common reusable components. So we've got schema components in there. We've got standard query parameters that might be used elsewhere. We've got standard response objects and things like that. So those are all part of those components. And then each individual API, whether it's an accounts API for viewing your accounts and your account balances, or it's a transfers API for making transfers, or a transactions API that lets you look at those transaction history for individual accounts, and various other elements. We do digital banking, so it's all kinds of banking related resources. Each one of those will have its own API model and its own API definition in OpenAPI, but they can reference schemas and other things from each other quite naturally. And that works really well with the composition model that's supported with OpenAPI.
Yeah, for sure. I got to double down here and say that, we're certainly big fans of James Higginbotham and his process. And you mentioned ADDR, and this is align, define, design, refine. And
Yes.
I think what a lot of what you just described is kind of the align and define part, right? Is like
Yes.
before
Yes.
internally at Stoplight, we tend to refer to this as like the homework that happens before you design. And it's like a lot of it is just marker boards and spreadsheets and Miro charts. And it's kind of a loosely defined thing that, you can't point to and say, well, go use that tool and it'll do it. It's about the discussion and about the alignment and having a shared definition of it.
Yeah, it's very much communication is just so central and key to that. And the notion of collaboration is really, really critical there.
Yeah.
Because it's interesting because, when I worked at SAS was and is hugely based on analytics, right? That's their bread and butter is analytics. But I never really learned or became an analytics expert. I didn't really know the domain model very well. I just kind of knew APIs and interfaces and kind of software design. But all the work that I did at SAS really wasn't analytics based. There were a lot of other people who were way smarter in PhDs in analytics, et cetera, who did all that work. And then at Apiture, I came into the company without any banking experience at all. So I relied very heavily on the domain experts to teach me the domain ideas, and so I learned quite a bit about banking, but I'm not a banker and I'm not a financial person. I'm an API person. But it's important for us to be able to communicate and work because, these banking domain people, they don't really know APIs. They don't know what's possible with APIs, or they don't know good ways to structure and manage an API program for evolution and things like that. And so it has to be teamwork there, and we kind of teach each other as we go along.
Yeah, I think it's one of the funner aspects of working on kind of, platform engineering, APIs kind of topics is you find yourself in all kinds of things. And these days, it's like, look around the room, there's APIs getting called right now, right? It's everywhere. It's in everything. Your fridge and your washer are talking to stuff. We're reminded of this a lot at Stoplight, where it's like, our top customers make like beer, electrical parts, shipping automation stuff, like very, traditional business lines. And you go, well, yeah, like at its core, integration was always about supply chain automation, right? So it's really interesting that, I did a stint in fintech and that sort of stuff. And I came away with a better understanding of it. But if someone said, describe how the payment stack of the world works, I'd be like, I'll tell you to talk to. But, I trusted them in the definition and just created the right guardrails so that it looked and smelled and felt like the other things. So I'm with you on that. I think back to our sort of language of APIs arc here. We touched on programming languages and some of that expressiveness and kind of how to define these domains. But I guess you mentioned in the course of that, OpenAPI is sort of the way that you're expressing those things.
Right.
and sort of kicking off the development process. So how do you see that sort of fitting in?
So we adopted OpenAPI at Apiture when I came in. I kind of said this is probably the best representation of how to capture an API design. There were lots of other competing standards at the time. There's RAML and there's API blueprints and all kinds of other things, but OpenAPI kind of had the momentum going in, and OpenAPI 3.0 had been out, and the tooling around that specification was really kind of the kicker. By having a well-defined and constrained language for expressing an API design, really enables the tools and stuff. So I have lots of issues with OpenAPI that I would like to change if I could. But there's lots of ways that I would really like to extend OpenAPI, and it goes back to, I think if you go back to like issue like 182 in the GitHub repo is one, an idea that I put in there many, many years ago. That hasn't been adopted yet, but there's a lot of people who seem to like that idea of just extending it a little bit in a different direction. But it's interesting because it has constraints, and constraints are really kind of important. If OpenAPI adopted everybody's wish and made all these changes, it would become untenable. It would become unusable. So those constraints are really what are interesting. And this was actually this was my last post that I published on my blog on the Substack, was about growing a language. And this is the 25th anniversary of Guy Steele's seminal talk of the same name. I was recording that was at the OOPSLA, it was Object-Oriented Programming, Systems, Languages, and Applications, an ACM conference that was held every year, and they've renamed to Splash since then. But 25 years ago, he gave this really great talk about growing a language, and he was on staff at Sun Microsystems at the time. Java was growing in popularity, and there were all these requests to extend Java in this direction or extend Java in that direction, add this new feature here. And he talked about how you go about growing a language like Java. And this applies directly to growing a language like the OpenAPI specification or growing a language like JSON schemas. And he talked about the forces that come to play and how you have to weigh all those forces and think about the long-term evolution and what's going to be sustainable and things. So it's a fabulous talk. If people have not watched it, it's really good to see. I think anybody who does any kind of software design, especially around languages, should really be familiar with that. So we adopted OpenAPI, and haven't regretted that by any means, because of the expressiveness that it has. Even though it's constrained, sometimes those constraints are really helpful to help you focus on what it is you're really trying to say. And with a constrained language, you can still have quite a bit of expressiveness. And it's kind of nice because it leads itself to a much more consistent view of what your APIs will look like, because you can't express completely wild and crazy different things. So anybody who's looking at an OpenAPI definition understands its structure, and they understand the meaning of all the constructs in that document, and things. So it helps with the understanding of the API. So that's what's really beneficial about it. In addition to it being a JSON document that can be parsed and processed and analyzed. You can use it for code generation. You can use it for creating mocks. You can use it for creating your documentation, and you can use it for creating SDKs and all manner of deployment methods and everything else. So it's really beneficial there. And it's proven to be pretty powerful and expressive given that constraint that it has.
Yeah, I mean, to some extent, what you're really describing is the design by constraints methodology applied to HTTP in general, right? Like Fielding was trying to sort of express the possibilities with HTTP programmatically. So
Right.
I think it even goes beyond that. I have to comment too on like the maintaining OpenAPI and how hard it is. I was actually part of the founding crew on the OpenAPI initiative, and alongside Ron Rotowski was supposed to be the referee for the group. And yeah, when you see all of the world's perspectives on how to design an API and have to make choices, it's hard. It's really hard. And my favorite example is stuff like discriminator in OpenAPI, and like the fact that it's never really quite worked right in any tooling. For my money is like, it probably should have never been there. Yes, people want to do that, but it's like every time I've worked with folks on why are you trying to build a polymorphic API, right? Something that changes its meaning depending on what you're doing. Usually there's a cleaner way to do it. And I think even to connect back to your earlier point that like, there's so many languages that express different things. The API designer's job is often to think about how to get rid of all that flavor and come back to really just the foundations of object-oriented principles, things that are applicable in every language. And it's a really tough set of constraints to work with, but it's kind of what makes it all work. So yeah,
Right.
it's tricky for sure.
Yep.
So, we're taking into account all these, sort of open API and expressing things and all that. And, I know one of the struggles historically has always been, you write down a bunch of rules and standards, and then you ask, all the developers in a company and really large ones, it's hard to even communicate that, hey, do it this way, right? And to sort of produce this feeling that a bunch of APIs feel like one thing, they feel like one platform. So, but that's hard, right? So, like, what's your approach to sort of building that consistency of design?
Well, you mentioned guardrails earlier, and I think that's an important aspect. So when I worked at SAS, it was a very large organization. So it was very hard to have people kind of have the same mindset, which is really kind of what's necessary. If you want to have a consistent set of APIs, and we had marginal success there, so, we had kind of API design standards, and we said, you should do it this way, you should avoid this particular practice, this is how you should name things and things like that, which only goes so far until you can really, and you can't codify a mindset in an API style guide. But you can certainly try to communicate again. And really the best way to do that is through examples. Now at Apiture, it was much simpler job because I was for a long time, for 4 years, I was the only API architect. I was the only person designing the APIs. So I was able to just kind of use the same style throughout and had that consistent voice.
It's good to be the king, right?
I'm sorry?
It's good to be the king.
Yeah. But even over time, that voice changes, and I can see where there are things that I designed 4 years ago that I would design completely differently today, and that's a really hard thing to really manage, especially for a larger organization. But the best way to go is try to keep in mind who you're writing these APIs for. They're written to be used and written to be consumed. They're not written to be put up on a pedestal and say, look how beautiful this API is. Isn't it elegant looking, right? The real judge of that is, can developers solve problems with the API? Can they actually consume it and use it? Can they adopt it quickly? Do they know how to use it? Can they infer how to use it because it's consistent, for example? So if you do something in one place, the way you do pagination in one part of the API should be the same as what you do in another part of the API. So selling people on that, everybody wants their software to be used. So in order to get people to kind of buy into any kind of governance product or a program or anything like that, it's the same thing as with user interfaces, right? If it's inconsistent, and it's going to be harder for people to use, it's not going to be as successful. So everybody wants their stuff to be successful. They want their APIs to be used. They want their user interfaces and programs and applications to be used, et cetera. So that's the primary thing is, can you solve real problems with it? And can you get the feedback from those consumers and developers early enough to tell you you're on the right path? Or at least later on, you get the feedback that, yes, I am using it and it is successful. And then you use that as a showcase for other people. So when you have new people coming into the company, you can point them to your history and say, this style of API works really well. This one that we put out there 2 years ago, no one's really using it. Maybe its design isn't really doesn't really meet the need and things like that. So there's a lot of good information coming about now around governance. So Arnaud Loré over at Postman is doing a lot of stuff writing about governance. And he takes I don't want to say it's a non-intrusive approach to governance. It's really, you have some guardrails, but you're really trying to lead rather than push, lead by example rather than forcing people to go down a specific path. But basically, if everybody is on board with the goals of the organization and why you're doing this work to begin with, then that's really what you use to incent people to come up with good, consistent APIs.
Yeah, and you had mentioned and written about kind of, thinking in dry terms, right? Don't repeat yourself. And I think that's a big part of what you're describing here. And I like to express it that your code base being dry is far less important than the community of consumption around that API and how dry that code is, right? So to your point on, can you have common, consistent patterns that are used across the whole portfolio of APIs means that the clients using more than one API just dried up a bunch of their code. And I working at like PayPal, where we have like 1 million developer network, right? I'm like, you add one line of code to that, and you just added 10,000 lines of code next month for all the clients writing against this. So if it's harder for you, fine. Like, let's do the right thing for the broad audience, because at the end of the day, their time is more valuable than ours in terms of growing the business. So I love that.
That's an important point, because I have to kind of sometimes clarify to the engineers who are building the APIs. They ask me, why you make my job so hard? And I'm saying, because we're trying to make the developer's job easier. Making the APIs easy to use pays over multiple times in the effort that we put forth initially. And a good example of that is, so we adopted RFC, 4707, the problem plus JSON, application problem plus JSON standard for a standard error response, or they call it a problem response, because it doesn't have to be an error, it could just be a problem. And we adopted that pretty early in our current cycle of new APIs that we're doing for our platform. And we use it, but we extended it. So you have a type field on the error, which is a URL that describes what that type means. And so we have lots of different ways of expressing lots of different types of errors. So when you have a 422 that says unprocessable entity, right? It's syntactically valid, but there's something inside of it that I can't deal with. It's internally inconsistent or whatever. So we have lots of different error types that can be associated with a 422. And sometimes people think it's really kind of hard to manage all those in the code base and generate the right errors and things like that. But it yields so many benefits to the developer, who, if you just return back 422 without explaining why, they're just lost, right? Or if it's a 400, why is it a 400? Well, give them some hints. And what we even do is we go beyond just describing what the error is with the detail. We also have like a remediation thing. How do you actually fix this particular error? So with every error type that we have, we also have remediation that says what you can do to rectify it. And that's there for the developers, to make the developer's job easier, so they get back reasonable errors from the system rather than just generic things that don't tell them any information at all. And the other part of this is, as you said, consistency. So since OpenAPI is a standard document format, we also have a whole bunch of templates that we use, and we have a tool to generate OpenAPI definitions from these templates. So you can really bootstrap an entire API by just adding a couple annotations to say, okay, I've got a resource here, and I want to generate some basic CRUDL operations, or I've got another resource over here, and I want to add some actions to modify it, or here's a singleton object over here, doesn't have all the CRUDL operations around it, but it's managed this way. And so we have 5 or 6 different patterns that we can express with a simple annotation, and you just code that briefly and push a button, and it generates all the kind of standard boilerplate around all those operations, and it puts in the security requirements for each of the operations, and it puts the tags in there, and it gives you response and request and response schema placeholders, and it just generates all this boilerplate for you. And then that lets you work on what's important, right? Because all that boilerplate, all that standard stuff that's always the same, you shouldn't have to deal with. You shouldn't have to write that. You shouldn't even have to copy and paste it. Let something else do it. And that's what this tool does. And that gives you a standard layout for all of your APIs. And then you just have to kind of fill in what's different, add your new query parameters to this operation, or define your schemas over here, et cetera. And then you can concentrate on the more interesting parts of writing an API, which is really kind of what you're doing and what the messages look like.
All right, I'm going to have to talk you into giving me a demo of this thing later. It sounds cool.
Yeah.
Shout out to Eric Vilda, aka Wild, for the Anglified pronunciation. Friend of the show who helped develop that the problem details for HTTP APIs, and I totally second that advice. Like, don't make up error models. It's so hard to do from scratch, and I really feel like they solve the problem. And it's like the number one thing people screw up when they first build an API is don't think about error flows. So
Right.
wonderful advice.
It's a standard like meme that we see on all these different forums around APIs is return to 200, error equals true. Don't do
totally. That. Yeah, don't break the basic rules
standard
of HTTP
for API design. Yeah.
Yeah. Cool. So I guess, as you know, we're kind of hitting time here. I'm sure we're losing listeners with boredom and other things to do. Any other sort of parting words of wisdom for us here? And I'm always empathetic to folks listening who are like overwhelmed by all the things you just said to do. Where would they get started?
Yeah. So we're really fortunate in that the API community is so open and accepting. So there's lots of different places that you can jump in. There's a lot of different Slack instances out there. APIs You Won't Hate is a good one. There's Discord servers and stuff. And then there are conferences. So API Days is going next week. I'm not going to that, but Aaron, our API architect, is. But there's the API Specifications Conference, usually in the fall every year. Hopefully they'll do that again this year. I haven't heard anything about that, but get involved with the community in one way or another, and follow what's going on with the OpenAPI specification and Project Moonwalk, which is, the next version, the next rev of that specification. Jump in and make your voice heard. The more perspectives that we have, the better off the environment's going to be. But there's so many people that you can call on. And if you don't have someone at your own company that can be a mentor, look outside your company and reach out in those other communities and say, hey, I'm kind of new at this. I know there's a lot to learn. Is there anybody who could kind of help me walk through my journey with me and help me grow and understand, the good ways of building an API program, the good ways of designing an API, the good ways of gathering requirements and sharing that align and define phase with my product team. How do I succeed with all these elements of API design? There's a lot of people out there. Reach out, and they're, as I said, they're very welcoming, and people really do want to help each other out. So join the community. Don't be afraid of jumping in, and you'll probably reap lots of benefits.
Love that advice. It's dead true. I think it's part of what sucked me into the API vortex is just, I don't know, people that speak my language,
Right.
and people who somehow, if they stay in it, have this innate will to try to describe the world, right? This is what we've been talking about is now that APIs are everywhere, we have to describe the world. So how do we do it? We got to put our heads together. Shout out to Phil Sturgeon for his APIs You Won't Hate, former Stoplighter and regular contributor. We love you, Phil. Well, David, thanks so much for being on. Tell folks where they can find out about all your writing stuff. You kind of mentioned it in there, but where do they go find you online?
Yeah, so it's on API Design Matters .substack.com. It's all one word. So the general Substack is called API Design Matters. So it's all matters related to APIs, large and small. And right now, the series that I'm doing is the language of API design, but that's just a short series that'll conclude. But the broader one is just API Design Matters.
Love it. Well, thanks for sharing everything with the community, and we'll all follow along. Thanks, David.
All right. Appreciate it. It's been a pleasure talking with you.
Thanks for listening. If you have a question you want to ask, look in the description of whichever platform you're viewing or listening on, and there should be a link there so you can go submit a question, and we'll do our best to find out the right answer for you.
API Intersection podcast listeners are invited to sign up for Stoplight and save up to $650. Use the code INTERSECTION10 to get 10% off a new subscription to Stoplight Platform Starter or Pro. Take a look at this episode's description for more details.